This is the mini lesson for lesson 1.2 found on page 16 in your textbook. Please mark the text with me. Each year, your class presents its mathematics portfolio to parents and community members. This year, your homeroom is in charge of the refreshments for the reception that follow the presentations. 4 students in the class give their recipes for punch. The class wants to analyze the recipes to determine which will make the punch with the strongest grapefruit flavor and which will make the strongest lemon lime soda flavor. The recipes are shown. When we look at all these recipes, I wanted to look at how many total parts there were as well. So Adams is made up of 4 parts of lemon lime, 8 parts of grapefruit. That means 8 plus 4. We have 12 total parts. So I did that for the 4 different recipes, which is actually what they're asking in question 1. So instead of writing it here, I wrote mine up above. Question 2 asks us for each of the recipes to write a ratio. Now I know that ratios look like fractions, and it needs to compare the number of parts of grapefruit juice to total parts. So I need to grab those 2 pieces, grapefruit juice, total parts. So for Adam, there are 8 parts of grapefruit, 12 total parts. You can continue to do the same for the other 3 recipes. Now they want to know which recipe is going to make punch with the strongest grapefruit taste, and we're to explain our answer. So I took the 4 people and I wrote those ratios, grapefruit to total, that we just found in the prior problem. Problem with that is I can't tell by looking at these fractions which is going to have the strongest grapefruit. I need to have the total parts be the same before I can compare. So I found that the least common denominator that I could use with 12, 8, and 5 is 120. So I scaled each of these ratios up. So 80 out of 120, 75 out of 120, 72 out of 120, and 96 out of 120 would be grapefruit. Obviously, the more parts of grapefruit, the stronger it is, so Zeb's recipe is going to have the strongest grapefruit taste. Some of you prefer decimals to fractions, and that's okay. I took each one of these. I took 8 divided by 12 to get 0.67. 5 divided by 8, 0.625. Same for these 2. And then I looked at these 4 decimals. This is the largest number, so it's got the largest amount of grapefruit. So Zeb has the strongest grapefruit flavor. And I did that one of 2 ways, common denominator, or I could look at the decimal. Okay, so what you're going to do now is continue on with problem 4, and you're going to do the same thing, but instead of using the grapefruit, you're going to use the lemon lime. When you're finished, have me check it, and then continue with the video. Problem 2 is a little tricky. So let's go back and read the problem. You're borrowing glasses from the cafeteria to serve the punch. Each glass, so that's kind of referring to the number 1, each one glass holds 6 ounces of punch. Your class expects 70 students and 90 parents and community members to attend the reception. You decide you're going to make enough punch so that every person who attends can have 1 glass of punch. How many fluid ounces of punch will we need for the reception? I first need to know how many total people are attending. There were 70 students, 90 parents and community members. That's 160 people. Each person gets 1 glass. Each glass holds 6 fluid ounces. So if I take 160, multiply it by 6 fluid ounces, I need a total of 960 fluid ounces. We're going to be coming back to this number multiple times. Previously, we wrote rates to compare parts of each ingredient to total parts of all ingredients. Recall that a rate is a ratio in which the units of parts or the whole being compared are different. So we're going to be using Adam's recipe here. So what I did just to save myself some time is I turned back to the recipes on the prior page and I rewrote that Adam had 4 parts of lemon lime and 8 parts of grapefruit. That was 12 total parts. We want to determine the unit rate. I'm making myself a note. Unit rate means we need 1 in the denominator for the fluid ounces of punch that would be in one part of the recipe if we use Adam's recipe. So again, we just found we need 960 total fluid ounces. And there are 12 total parts in Adam's recipe. So I wrote that as a fraction. I'm bringing over my label, parts, fluid ounces. I want to know for one unit rate, so that's a 1 in the denominator, how many ounces are in one part. So if I take 12 and divide it by 12, I'm scaling down. 960 divided by 12, that's how I got 80. This I'm going to be using multiple times now. Next question asks me, how many fluid ounces of lemon lime soda and grapefruit juice are needed to make enough punch if we use Adam's recipe? So again, I'm using Adam's recipe. I'm using this ratio. So I'm going to rewrite this. I'm going to first do the lemon lime. So 80 fluid ounces is one part. Lemon lime had 4 parts. So I have 4 parts of lemon lime. I'm scaling up times 4 times 4. We will need 320 fluid ounces to make the 4 parts for the lemon lime. I'm doing the same for the grapefruit. We use this ratio again. 80 fluid ounces is one part. His recipe has 8 parts of grapefruit. So I'm putting 8 parts down here. Bringing over my label, 1 times 8 is 8. 80 times 8 is 640. So I need 640 fluid ounces of grapefruit juice. I can quickly check this. If I have 320 fluid ounces of lemon lime, 640 fluid ounces of grapefruit, if I add those, I better get the 960 total fluid ounces, and I do. If you feel that you're ready, then I'd like you to continue on to problem 4 on your own, then come back and check it. If you're still not there, I'm going to walk you through one more. This time we're going to use Bobby's recipe. So I did the same thing. I wrote down his recipe. He had 3 parts of lemon lime, 5 parts of grapefruit. That's a total of 8. We found out we need 960 fluid ounces, and Bobby had 8 parts total in his recipe. I want to know how many fluid ounces for one part. So I scaled down for one part, dividing by 8. Dividing by 8, I found I need 120 fluid ounces in one part. Now I need to know how many ounces of lemon lime, how many ounces of grapefruit. So I'm using this ratio. So I rewrote this. And there are 3 parts of lemon lime, so I'm putting my 3 here. I'm scaling up times 3 times 3. I get 360 fluid ounces of lemon lime that I need. Same thing over here for the grapefruit. I'm using this ratio again. There's 120 fluid ounces in one part for Bobby's recipe. Bobby has 5 parts of grapefruit, so I'm scaling up to get 600 fluid ounces. So if I have 360 fluid ounces of lemon lime, 600 fluid ounces of grapefruit, when I add them together, I better get 960 fluid ounces total, and I did. Now I would like you to continue with problem 5 using Carlos's recipe, 6 using Zeb's recipe, 7 you're going to be writing some of this into a table. When you get through problem 11, I would like you to stop, call me over to you, and then we will take a look at how you did, and then we'll get the homework for you.